So they basically, when they are called, whatever you input in it, or that call, when the function result will place that will be in place of that call. So they return a value, the value produced by the function. So for example, it could be an integer, float, or string. Having obtained the result from the functions, something is done with that value. So for example, result might be displayed, assigned to a variable, or used in calculation, and we see example of that. Just like void function and just like variables, we use the camel case, and also we need to give it a descriptive name so that it's easy for people to understand. Some of these function predefined one is cube or round or sphere value. So what happened when we call a returning function, or return function is called? So execution jumped to the start of that code, just like the void one. Then the code for the function is executed. Then the execution return to the line where the function was called. From then, the return value substitute in place of the function call. I'll show you what that means in the examples below. The statement the function is in is executed, example, calculation, display, or whatever that we're doing with it. So an example of that, for example, calling a function. We have the variable x equal 12.7. We want to call a predefined return function to round to that number, so to the nearest whole number, and then store that value that we just rounded to a variable called I. So I equal round x. So where he says the return value is substituted in place of the function call, so when rounding a function will work, and we put that number in it, naturally you can imagine the nearest whole number to 12.7 is 13. So now we substitute round bracket x, which is the part that we're calling the function, with the number 13, because that's the return of that function. So now instead of I equal round x, I will equal 13, because there was a return from that function call. So in here it says print x and the print I. So we want to display the value of x and the value of I. X will equal obviously 12.7. That's what we start with, and I will equal 13, which is the rounding of 12.7. This is another example of print round 12.34. So we're going to substitute that function call in the box with the value that it will return. So the return of the 12.34 is 12. So now you can imagine as if we're saying print 12 comma millimeters. So when we display it as that. In here we'll show you how that happens. So x equal 12.7. Then we called. We wanted to find the value of I by calling the function round x. So the call round passing value, we're passing the value 12.7 to it. The function, first line of that function will calculate the nearest integer to x, which is happened to be 13. And then it will return the number 13. Will now substitute the value 13 from the function call. So now instead of having the round, instead of having the function call, we now have a value. Then we're printing it. Similarly with this one, we're calling the round function. We're passing 12.34 to it. we calculate the nearest integer to it, and we return 12. And now we substitute that call with the number 12. On this second example, we call a function in a calculation. The function call shown in as a box. So this is the part where the function is called. So we have the x equals 4 call a predefined square root function. So this is already exists. That function exists in Python. And what it does is find the square root of the number is passed into it. So y equal math square root of x plus 7. So if you imagine how this will work is we will jump to this function, we're passing it the number 4, we found the square root of that number, which is 2. Then we substitute that function call by the returning value, which is 2. So it becomes y equal 2 plus 7, which is 9. Let's have a look at the, so this is another example. This is basically how it's executed. Review questions. So we want to give us the result. So think about this one. Result of the following calculation showing full working with one operation performed per line, assuming the amount, the value is 123.4183. In general terms, what do the calculation do? So in the first line, we want to show us what's the round. So this is a variable called rounded amount 1, and basically we're calling the round function, and we're putting this amount, we're passing it this amount multiplied by 100 and divided by 100. So what will be the rounded number as a result of that calculation? Second one is doing it for, we multiply it by 10 and divide it by 10. And then we want to know how would you round number to 3 decimal places? So have a think about this one. Remember what's the calling of the function does. It goes to the function and imagine there's an amount here and do your calculation. Spend 2 or 3 minutes doing that. All right, let's have a look at how we resolve this. So we want you to imagine that we're multiplying the amount by 100 first. So that's what we're doing in this part here. So that will give us 2 decimal numbers. And then so the number that we're rounding is 1, 2, 3, 4, 1.8. And because it's 0.8 is now when we round it, we add 1 to end of that. And then when we divide it by 100, this is the number where we're going to get 123.42. When we do that with the 10th, that basically make the number 1234.1. And when we round 1, there's no addition to the 4, so it stays as 1234. And then we divide it by 10, it gives us the number 123.4. So that rounded to the nearest 10 cent. When we ask to round it to 3 decimal numbers, so that's when we multiply by 1,000 and divide by 1,000 to get that. So how the syntax looks like for function that return a value. So in the CETA code, calling a function is executing the function, do the whatever instruction that inside that function, just like the void one. But the difference is it will substitute the result where the function was called. So defining a function is starting with it. We'll do when it's called. Set of instructions. So calling a function, just like we did with void, we call a function name followed by a bracket, or we could pass in parameters. Declaring a function, then declaring a function. So in CETA code, we have the function name, the statements, or whatever the steps that it's performing when that function is called. And then end with return a value. Similarly, if we have parameters, we could pass in the parameters and their types, and then return a value. In Python, calling a function is again like void, is function followed by a bracket, or function name followed by bracket, and then we put we're passing parameters. And the way we're defining a function is like void, we use the word def to define the function, but the difference is we return a result, whereas the void one doesn't return a result. So in this example, example 1, cube and sphere volume function. So CETA code for that is we want to call that program function example 1. We have the variable x equals 5 and y equal, we call the function cube of x plus x multiplied by x plus 4. And then we want to display x and y. Then we wanted to input radius to calculate the volume using the function called sphere volume. And we use the radius that we've inputted there, and we display it. So these are the variables we called, and in this function, they're all local to that function, the main function. So when we're calling cube, number floats. So we're calling the cube with this, and we having inputting a number there, and then we're saying the type of it is float, and whatever is returning from this will be float. And the cube result equal number by multiplied by a number multiplied by a number. This is how the cube result works. And then return the cube result. So this is the function there. and then sphere volume. So this is the definition of this function that we're calling sphere. So we expecting what's coming from there. It's a value that it's top float. So just want you to notice here, we input the variable called radius. When we called it with, and we inputted radius. However, how we assign that variable inside the function, it's up to us. So when we define this function, which is here, we decided to call this variable r. So we're not restricted to call it radius, because this function understands that this variable here, whatever I call it in the definition of the of this function, it comes from whatever value it's been populated in here. I'm deciding that this will be a float, and we're returning it as a float. So we calculate the volume, and then we're returning the volume. So whatever that variable will be here, whatever the value that variable will have, it's what we're returning as a result of that call. And then variable volume will be assigned to whatever we're returning from that function. Does that make sense? Are we still following? It's a bit complex. As I said, like when I was looking at these lectures, I think the best way is for you to start doing some practice to understand how that works, because there's a lot of jumps and back and jumps and back, so you just need to understand how that works. I'm gonna skip the disk checking, but I highly recommend you do it. Put it two next to each other and follow the code. That will help you understand how that works. For the Python code to do that, so we're defining the main function of this program, in which we declare the x variable equal 5. Then we declare y. We call a new function called cube2, and then we do some calculation, and then we're printing that. Then we input the radius, which then we inputting it here. And then we're calling a new function called sphere volume, passing in whatever we inputting in here. Then we're printing it. We have two functions that we called here. This is the first one, and this is the second one. And then we need to define these functions. And remember, all this we're doing here is we're defining the main function. We're defining the two sub-function, which is cube2 and sphere volume. All that before we actually executing the program, because really the point where we're executing this program, it's all the way here at the end. That's when we're calling the main function, which executes all these lines of the code. So we're defining the cube, and whatever we're passing in it. So we're passing x. We wanted to give that variable a different name in the function. We call it a number. We do some calculation on that number, and then we return as a cube result. Similarly with the sphere, we wanted to call whatever variable we're passing, we're calling it r. We're using it locally here, the r, and then we're returning a value. Second example is to return a leap year function. This function would be good to use in that example where we were returning the numbers of days in a month. When we did that program, we were unable to identify whether there was a leap year or not. So we defaulted the month of February to 28 days. So in this function, we input the year, and while the year not equal -1, so -1 is our sentinel value, which will stop the loop. We then, once it's not equal to -1, that means we've entered a year. We wanted to check if that year, so we're calling a returning function call is leap year, and we're passing the year that we inputted at the top. If that's true, then we display it's a leap year, else we display it's not a leap year, and then we end. So that's the main part of the program, and then this is a new function that we created. In that function, whatever we're passing into it, we call it year number, and we wanted to have it entered as an integer number. However, what we're returning is a balloon, so true or false. If the year mod 4 equals 0, so when we divide whatever that year by number 4, if there's no, if it's the mod is equals 0, then we decide this is a leap year. Otherwise, it's not, and we return the false. And then we return that variable as leap year. It's a balloon type. It's either true or false. So the way that runs, so we're defining the main part of the program where we're entering the year, and we'll prompt the user to enter the year or -1 to exit that loop. For as long as that we haven't chose to exit, we check if that year we have entered is a leap year or not. And then we print the results. If it's true, we put as a leap. If it's not, we print it's not. And then we prompt the user to input either another year or exit that loop. Then we define that function that we're calling here, which is determine whether it's a leap year or not. In that function, we so define its leap year number. We divide the year number we entered by 4. If the mod equals 0, then the leap year is true, otherwise it's false. Then we return that value. Notice how we, in the serial code, we wanted to show that clearly what we're doing. But it's not in here. The program just understands what we're doing. This is just an optional. There's more calculation to decide on the leap year, so you can do a bit more to get that. So in your free time, spend some time performing this checking on the leap year example using the following. So use year 19, correct result that 19 is not a leap year, and then use 20, correct result is 20 is not a leap year. And then input the year -1 to exit from that loop. I can show you an example of how it's going to look like. Take a screenshot of it, but I really want you to do it yourself.
Oh, but isn't 2020 a leap year?
I thought so, because I divided it by...
Yeah, 2020 is a leap
year. Yeah, I got a leap year as well.
Yeah, me too. when I was reading it, because when I did my calculation yesterday, it was a leap year. I'm just surprised. Remember, this is not my lectures materials, so it could be a typo. Is not a leap year, is not leap year. So maybe this is a typo, because see how it says it's not a leap year, and then he says, so he probably meant to be deleting the A and not, and he just deleted the A. Because if you divide 2020 by 4, you would get a mod of 0. So it should be a leap year. But anyway, this is actually he doesn't here. True. It says, yeah. See? Oh, what did I do? Yep. So when I did that, it came up as a true. All right. So this is example 3 is membership problem. We're revisiting that. From problem description is the club membership fee, again with validation of input and void function. So the main function is total fee is equal to 0, membership type equal input valid. So this is we're calling a first function input valid membership type. While membership is not equal to x, then we wanted to call the second function, which is calculate the membership type. Then we're doing the addition. And then again, we're calling the first function, which is do the validation. So that's the main part. The first function that we call it, the valid membership type, and what we wanted to return is a string. So whatever it's that type. So input membership, while membership not equal this valid value, then display the error message. Otherwise, we want you to exit that loop and return to membership type. This will return it to the main program, which then subsequently calling the calculation of the membership type. And while it's the value that we enter to this function is a string, so it could be fj or f. What we're returning is an integer, because we wanted to return the value of membership fee. So we're returning the membership fee. So that's explain what we're doing here. We're expecting a membership type that is a string, and we're returning an integer. And this is just this checking for this. The code. So again, remember, we're defining the main function. We always start. We cannot. I want you to always remember that we can't execute. We can't call a function that we have not yet defined. And the way Python works is from the top to the bottom. So we need to be able to define all this function before we actually calling that main function that we're creating at the start. So we're defining the main function, and I want you to pay attention to that. If we were not using function, we will not have that part in here. The reason we have now for the main part of the program we define it is because we're using function in the program. So we're defining the main part, which does all the calculation, but it does it by calling sub functions. So we're declaring first the local variable of fee equal total fees. Then we're calling the validation function, which we're passing it sorry, this is a void. So membership type equal input valid membership type. while the user hasn't finished, so while we don't have X, we wanted to then call the second function, which is the membership fee. And we're passing, for this one, we're passing the membership type. Then we're doing all this calculation. Sorry, I said this is not void. This is actually a return one. So we're inputting the valid membership function, where we want to check that it's the value that it's been entered is it's valid. And the second function is the calculate membership fee. All right, that's it for today. As I said, like with this with function, because we're jumping in the code, it really be worth it to have a look at a few of the disk checking. Do the ones that here it will help you understand how the code follow. And also hopefully in the tutorials and lab, we'll have a better chance to practice on creating programs using functions, and that will aid your understanding of them. Do you have any questions about these ones? Or any comments? Yes, all good. All right. I'm going to be available for any consultation if you have any question about this or other issues. But I will not be on. I will be closing this Zoom and then creating a new one, which is the consultation Zoom. So if you have any question, come to the consultation Zoom. Okay. Otherwise, I will see the rest of you tomorrow.
Thank you.